All right. So now, if you're watching this, you should have reviewed the video that explains inputs and outputs for arc cosine, why the domain and range are what they are. Okay, so just as a brief review, we have this new notation where arc cosine is the exact same thing as inverse cosine. Okay. So writing this statement, ARCCOS, or writing cosine with an inverse, it doesn't change what we're doing. All right. The inputs are, because this is cosine, right? The inputs are x coordinates. So this is an x coordinate. And the output is an angle on the unit circle that we can find. Now, the domain is from negative, that should be brackets, from -1 to 1, and this does fall in that domain. And the range is from 0 to pi. So what that means is we're only looking at angles starting at 0, rotating all the way around here to pi. Because if you think about it, all of the points that move, from this point all the way over to here, we have positive x values from 0 to 1 over here, and we have negative x values from 0 to -1 over here. So that covers everything, right? That covers the entire domain on just the top half of the unit circle. So we're never going to include any of this when we're doing an arc cosine problem. So when it comes to identifying which pi value has an x coordinate of negative radical 3 over 2, here's negative radical 3 over 2 as an x coordinate. It is the angle 5 pi over 6, and 5 pi over 6 is between 0 and pi. Okay, if you're contrasting this with arc sine is a little weird because we're using quadrants 1 and 4 only, and we have to label the angles down here as negatives. We don't have to worry about that with arc cosine. Okay, so arc cosine is pretty straightforward. As long as the angle, as long as the number that's in here is between -1 and 1, then we can use whatever angle we find on the unit circle that has that x coordinate. We don't have to change it to a negative or anything like that. Okay.